Let's say that we have a text, or we have an image, or we have a PDF file. If we give that as an input to a hash function or a hashing algorithm, as a result, we get the fixed length of output. So what is a hash function? Hash function takes your input and applies a series of mathematical operations to generate fixed length output. So for example, no matter if your input is hello or an entire book or entire PDF, the output of the SHA 256 algorithm will always be 256 bits long. So for example, let's take this very simple example. In this case, we have an input hello world, and we are applying SHA 256 algorithm here. So we are giving to algorithm input hello world, and as a result, it gives us a result as a hash result of the fixed length 256 bits. So let's do following. Let's change the one letter from the lowercase to the uppercase in this input. So what will happen is, as a result, we will get the completely different output. If we compare these two results, as you can see, they are completely different, but we changed only one letter. So that's the power of the hashing algorithm or hashing function, is that let's say that you have an entire book, and in that book you change only one letter, and the output of the hashing algorithm or hashing function will be completely different. So what are the features of the hashing? The first one is a digital fingerprint for a data, and another one is even a small change in the input completely changes the hash. As we have seen earlier, even let's say you change that from the lowercase to uppercase, so whatever change you make, it's reflected in the result of the hashing function. And another one is that one of the important features is the hashing is one way. That means that once the data is converted into a hash, you cannot reverse it back to the original data. Where hashing is used, right? Hashing is used everywhere, starting from the data structures to the file transfers and so on. So the first use case, first real world example would be that the data retrieval with the hash tables. So for the fast lookup in the data structures like the hash table. So for example, in the data structures like a hash map in Java, or let's say the dictionary in Python, we are using hashing. So also another one is that for password storage and the verification. So when we are storing a password, we never store that in the plain text. So what we do is we are applying a hashing algorithm, and then we are storing a password. And then the next time when the users inputs the password, so what we do is we receive that password, and we again apply we again give that as an input to the hashing algorithm, and we take the output and we compare the result that is in the database. So the next one is it's used for the digital signatures, it's used for the data integrity and the verification. So for example, let's say that we are transferring a file and we want to make sure that that file hasn't been changed during the transfer. So what we do is we are generating a hash code. We are generating a hash value for it, and we are passing along with the file. And if the file has changed during the transfer, then in that case the hash value, even if we change a one letter, right, let's say as we have seen earlier, then the hash value will be completely different. So another one is that we are using that for the checksums and the error detections. We are using algorithms such as the CRC32 for it. So we are using for the file and the data deduplication. Again, when we are receiving a data, we, instead of comparing the whole data, we are using a hashing algorithm, and we are giving a data as an input, and we are comparing the output with the previous value in order to detect the duplicates. Also, we are using that in cryptographic applications. We are using that in caching, and we are using in the blockchain. In the blockchain system, each block contains a hash of the previous block. This creates a secure and unbreakable chain of data. So the name of it is the name blockchain is coming from there. So what are the popular algorithms, right, that we are using for we are using for the hash functions, for hash algorithms, popular hash algorithms. The first one is MD5. It's used for the file checksums. We have SHA-1. It's used in the legacy systems, and also we have SHA-256. It's for modern security and the blockchain. For the high security applications, we are using SHA-512. And for the secure password hashing, we are using bcrypt and the Argon. So another algorithm that we are using for the secure password hashing, bcrypt, Argon, and also we are using scrypt. So another question is that it's always confused that the difference between hashing and encryption. What is the difference between them? Hashing, as we have seen earlier, hashing is irreversible, right? It's only hashed if it's only hashed in one direction, meaning that once we hash that, we cannot get the original data back. But the encryption is reversible. So when we encrypt that using the decrypting key, using the private or public key, we can reverse the data back to original state.